Now that you know the basics, you can start doing some more advanced stuff to increase your productivity with the terminal. One thing that you can do is define shorthands for longer commands, and we call these aliases. Aliases are useful for commands that you find yourself reusing again and again, especially when they're long to type out. So let's say you wanted to create a log of notes from the terminal. You could do that by echoing a note and redirecting it into a file. And then if you cat what's inside that file, then you can see it now contains that note. But that's a bit long. So instead, what we could do is we could define an alias for this whole command, which will be a shortcut for whenever I want to run that whole thing. To do that, I can use the alias command, followed by what I want the shortcut to be. I'll call it note. So anytime I run note is going to be equal to whatever I put on the right-hand side of this equal sign. And here, inside those single quotes, I'm going to put the command which I ran previously. Now, whenever I run note, it's going to run all of that. In this case, it's actually the same as I put above, so let me just actually change that so you can see the difference. So now if I run note, and then cat what's inside that file, you'll see it now contains whatever was defined in this alias. The problem is that it's going to always input the same thing into the file now, because I've literally hard-coded the note in there. There was no way for me to specify what the note was when I ran that. So instead, we need to find a way to follow this by arguments and then use them in this alias. The way you can access arguments to a command in Bash is using a $sign followed by the index of an argument. So if I were to change this and replace this my notes with instead $1, now it's going to echo the first argument into that notes file rather than just whatever I've hard coded there. So if I run that and then write note hello, and then cat whatever's in that file, you can see now it contains hello. And in Bash, you can do the same thing with arguments other than the first one as well. You can do $2 to get the second argument and so on. One thing I need to change is that this is currently overwriting instead of appending. So with a double angled brackets, it's going to append to that file rather than overwrite it. So now if I run note hello again, cat what's inside, it's going to have 2 hellos in. And I can write note whatever I want now. But another problem with this is that these aliases won't persist after you close this terminal. So how do you get around that? Well, firstly, you need to know that when you open a terminal, it will automatically run some particular files. And by default, a bash terminal executes the .bashrc file in your home directory. This .bashrc, because it starts with a dot, is a hidden file. Because every line in this file is run on opening a new terminal, adding aliases to the .bashrc file means that they'll persist for new terminals, because every terminal that opens, it's going to run that file, and that file is going to define all of those aliases. You can see in here I've got a few other aliases defined. So now, even if I open up a new terminal, I will still be able to write the notes into my file. Editing the .bashrc file is useful for anything that you want to happen every time you open up a terminal, not just aliases. And one of the things that I often use it for is setting variables. We call these variables, which are set as part of the environment which the terminal uses, environment variables, and they conventionally have uppercase names. In Bash, you can access variables defined in your working environment by writing their name after a $. The $sign tells Bash to evaluate the variable rather than use what's literally written. Some of the environment variables that I think are worth noting are path, which shows you all the places where Bash will look for commands it can run, which are known as executables, separated by colons. Python path, which shows you all the places where the programming language Python will look for libraries it can import, again separated by colons. And home, which is the absolute path of your home directory, which somewhere the tilde character is actually defined as an alias for. Some other industry software like Spark, MLflow, and Kafka require you to correctly set environment variables too, and so it can be useful to put these in a .bashrc file. And you can see that I've got a bunch of environment variables defined in my .bashrc file. To define those environment variables in Bash, use the export command, followed by the name of the environment variable, and then the value. Everything that I've shown so far is built into the terminal, meaning it's installed and it works by default. I'm sure you can imagine though that it would be useful to install more code written by other people. And to do that, you need to use a package manager. There are different types of package managers for installing code written in different languages. For example, you would use a Python package manager to install third-party Python code. But for third-party terminal software, we use a system package manager. And if you're on Linux, your package manager should be apt, A-P-T. You can use apt to install software by doing apt install and then the name of that software. That's not going to work on my Mac though. I'm going to need a different system package manager, which in the case of Mac is brew. So if I wanted to install third-party software for my terminal, I'd do brew install the name of that software. If you're on Linux, you'll already have apt installed, and if you need to download brew, you can simply look up how to do that, get this command, and run that in your terminal, and that'll install brew. And if you're on Windows, you shouldn't still be on Windows. So let's have a go at installing a nice little third-party software within the system package manager, which is a piece of software called tree. So I'm going to run brew install tree. Cool. It seems to have worked with no errors. So now I'll be able to use that tree command in my terminal. What tree does is it shows you the structure of the different files and folders in your system. I'm not going to run it here from my home directory because there's probably too many to make it clear. I'll run it from somewhere else. So here's what's in my videos folder. In the tree structure, you can see at the top, there is one folder called command line. That's got 2 folders inside. One of those folders has another one in, and that folder contains 2 files. Now, when you try and run these kind of installs, you might get a permissions error. These are often implemented not just for security, but to prevent you from doing anything silly like deleting part of the operating system. So now I need to tell you about sudo. Sudo is a command which takes in a complete other command, arguments and all, and runs it with admin permissions. We often call the role with these elevated permissions the super user, which is where the name sudo comes from, being short for super user do the following command. So let's sudo our install. Note that it asks you for a password, and this is just your laptop password, but when I start typing, it doesn't show up. That's not because it's not working, that's for security. So don't worry that you can't see anything there. This one's actually not supported anymore. But anyway, you might get other permissions errors where it says, you don't have permission to do this. If you're comfortable and you know it's something you should do, you can sudo that command. And note that, of course, to run sudo, you must have admin access to your machine. So if it's someone else's computer or a work computer, you might not be able to run that.